Hi everybody, welcome to Syngenta Nordics live event. I hope you can all see Marcella's screen. And first of all, Marcella will have the presentation. It will be in 45 minutes. And then we have 15 minutes for Q&As. So if you have any questions you want to ask afterwards, please, you can use the chat, send them there, or you can just ask them to me. I will note them down and we can take them in the end. All right. So I think Marcella will soon start her presentation. So Marcella, should you start?
Let's start. I will first introduce myself, and also I will introduce Veronica, because this is going to be a double act. So you don't get tired of listening to me for 45 minutes. We have Veronica here to break, that time and presentation. So I'm Marcela Muñoz. I'm the technical manager for turf and landscape for Europe, Africa, and the Middle East. I'm a sports turf specialist, play football, and I think it's the best description I could do. So I'm really, engaged with what I do. I'm very passionate about it, and I have been with Syngenta for the last almost 6 years in this role. And part of my role is to support customers, do a lot of this type of presentations, do a lot of trials work, and part of this trial work experience, I am working for the last 4 or 5 years with the Polytechnic University of Valencia. Sorry, Veronica, I need to say Polytechnic, where I met Veronica and Diego Gomez, her advisor and professor, and we have been working on biostimulants for quite a long time. So I will leave it to Veronica to present herself, and then we will kick off the presentation.
Thank you. Well, hello everyone. My name is Veronica De Luca. I'm agricultural and forest engineer. I work as a researcher at the Polytechnic University of Valencia, Polytechnic, in Spain, in Valencia, in Spain. And well, I'm also doing my PhD thesis related to amino acid-based biostimulants on some turf species under stress, mainly abiotic stresses. And Professor Dr. Diego Gomez de Barreda directs my thesis. And well, I'm here helping Marcela.
Representing the university and telling you from her own experience how these products work and how the research is being going down there. So just to explain you a little bit, this presentation is going to be about amino acid based products. Veronica will first give us an introduction about this biostimulant kind of a scenario and where these products might fit there or not. It's a very general explanation, and then we will look more in detail the amino acids or amino acids. I don't know how to pronounce it, but here, this is for the Nordics, so nobody in this call is like really native English besides, my UK colleagues. So sorry about the pronunciations. If you have any questions, just shoot and Lars will answer back. We'll translate for us as well. So we will cover this first part with the biostimulant, introduction, and then we will, we will jump into a product called HiCure, that is an amino acid-based product. We will look at the characteristics of this product, and then we will look more in detail about the research that we have, the results also that we have with these products that are kind of very different, I will say, from what you can look, out there in the industry in general. I will then move into more like practical recommendations, how to use the products and how to use it in a program as well. So I will leave it first to Veronica to start with the presentation. I will give her control of my screen. So
yes.
If we are a little bit slow, might be because of this new system where I can give control of my computer. Okay, Veronica, I think you have the power.
Mm,
There you go.
let me, yes. Well, I would like to start talking about the term biostimulant in Europe. Regulations about biostimulants vary across Europe, but this situation is changing as the European Union has recently published a new regulations where the term biostimulant is included. And it is defined as here, a European Union fertilizing product, the function of which is to stimulate plant nutrition processes independently of the product's nutrient content, with the sole aim of improving one or more of the following characteristics of the plant or the plant rhizosphere: nutrient use efficiency, tolerance to abiotic stress, quality traits, or availability of confined nutrients in the soil. And here you can find where you can, if you are interested to read this new reglement, is here. It's available here. Well, I forgot to say that this new reglement will come into force in 2022, and only separate in microbial and non-microbial plant biostimulants, which is not very specific, but it's an important advance. And in fact, if you do some research, you can find a few reviews based on biostimulant categories. In this slide, you can see a biostimulant proposal made by the author Dujardin, and he proposed these categories: humic and fulvic acids, protein hydrolysates, amino acids, seaweed extracts, and botanicals, or etc., beneficial fungi or bacteria. For instance, the Spanish government has published a new royal decree in which the term biostimulant is not specified, but it does include all these categories proposed by Dujardin as part of a new category called other special products, but it's a fertilizer. All categories are included in the list of fertilizers, just for you to know. The information related to biostimulants on turf is limited, although this situation is improving in these last years. Web of Science or Scopus are two scientific research tools where one can find peer-reviewed papers, but it is important how to look for the information. Look at these numbers. If you look for the term biostimulant linked to the turf grass, there are 15 or 21 published papers. But if you filter by searching amino acids instead of biostimulants, those numbers increase. But careful, because for example, in the Web of Science case, only 8 out of 63 papers talk about the use of amino acids on turf. And it exists searching tools as TGIF here, which is a project. For example, this tool is a project between the American Golf Association and the University of Michigan, where the information is more friendly. As one can find simplified science articles, as you can see in the example, with urea and trinexapaketil on agrostis, the number of the articles skyrockets. And this is the most interesting part. As HiCure is a product based on amino acids, we are going to refresh what an amino acid is. Amino acids are the basic units of proteins, and there are 20 amino acids in plants. This is the basic structure: an amine group, a carboxyl group, and a side chain, the R group, specific to each amino acid. Plants absorb L-amino acids. That's an important point. Those amino acids are manufactured in cells and incorporated into proteins. And next point, this point here, is very interesting as it's a summary of the most important amino acids that some authors found in response to some stresses. For example, we know that proline is accumulated in plants under hydric, salinity stress, or low temperatures, for example. Or glycine under hydric or heat stresses, for example, or methionine, alanine, or serine are also involved in drought or heat. It's part of our response, the plant response, or for example, there are some tolerant species that contains a higher percentage of those amino acids in their cells. It's your turn.
Okay, my turn. Just to complement a little bit of what Veronica was mentioning about regulations. The Nordic countries are also different. You have this European law that it will come into place by 2022, but then also you have countries do their own thing as well, as she mentioned the example of Spain. So if you want to know more about your specific country regulation, then maybe you can ask Lars about it. But so far right now, we don't have any regulations in the Nordic countries for this biostimulant category of products as far as I'm aware. So we will talk about HiCure as an amino acid-based product, not as a biostimulant, because we don't have that category right now in this territory. And another thing that also I wanted to link for what Veronica was mentioning is that we are really interested in knowing our product inside out, and we try to learn also from the previous research and publications, and there is not too much out there about these type of products. To make decisions science-based in this case, we are kind of beating a little bit of leaders because there is not too much. So even the methodologies that we came up to do trials are kind of different, and Veronica will tell you more about that. So just to complement what Veronica was saying. So now I'm going to move into HiCure. And what is HiCure? So as I mentioned before, it's a product that is amino acid based, and it contains 63% of amino acids and peptides from natural origins. That's important. And from the 20 amino acids that Veronica was mentioning, HiCure contains 18 of those amino acids. It's very high in proline, glycine, and glutamic acid. As Veronica mentioned before, those amino acids are key for the plant when they are under stress period. So there is a reason why we have this specific concentration and composition of amino acids. It contains 10% of organic nitrogen. So I know that especially for greenkeepers, managing their fertility program is very sensitive. So it's important to know that it's a very good source of organic nitrogen. And in total, it contains 11.5% of nitrogen. That means that only 1% of the product is an inorganic form of nitrogen. So it's really not very relevant if you start making your calculations on your fertilizing program. And if you want to apply this on top of that, the amount of inorganic nitrogen is very low. However, we consider that when we were doing our studies, we always try to compensate the inorganic nitrogen so we could understand specifically what HiCure was doing and not, jeopardized by the content of this inorganic nitrogen. That is very small, by the way. And also, Veronica mentioned that the plant can only uptake the L configuration type of amino acids. There are two configurations of amino acids, and I think that's a very important thing to understand, because there are a lot of products in the market, or even if you're looking for something different, you might be very excited because you find amino acids in some product, but you need to be sure that they are in the configuration L, because the other configuration is not available for the plant. So that's a very general view of the composition of HiCure. And I will talk today about the benefits of HiCure, but we will focus on some specific things. So HiCure will help you maintain your turf quality, but specifically during difficult growing conditions. So it's not like a pigment, for example, rider, that you can apply it and see an effect right away. This is conditioned by the stresses that the plants are coping with. So what HiCure will do will help you reducing the impact of some of the abiotic and biotic stresses. Specifically, we are going to talk about today on cold and heat stress, disease, and recovery. We have a lot of information, and it's absolutely a fantastic product for drought, but because of the Nordics, weather conditions, we thought that we will focus on these other three stresses. However, we have the information to share with you if you feel you need it. And the benefits related with these stresses are all related with the physiological benefits of HiCure. And we have learned that there are two key physiological responses that are really important for the plant. And one is related with the energy that the plant needs to produce. And HiCure boosts this plant's energy and help maintaining this energy through these tough periods, and also provides osmoprotection. So we are going to cover these two topics a little bit more in detail. So as I mentioned before, some amino acids are more important than other ones. In the case of HiCure, the biggest concentrations, like for example, we're talking about 130 grams per liter of, for example, proline. The proline and the hydroxyproline acts as an osmolyte, and it protects the membrane structure. So that's very important when we're talking, for example, about drought or cold tolerance. The glycine helps also as an osmolyte and is a precursor for chlorophyll. The glutamic acid, it's a building block for other amino acids. So that's very important because we are going to talk here about building blocks. We are trying to help the plant to construct proteins. It's also a precursor of chlorophyll, and it has a key role on the nitrogen assimilation. So that's also related with this conservation of energy and helping the plant produce what it needs when it cannot have easy access to energy. And also the alanine, that is a precursor to a lot of plant hormones. So just to mention, we can give you, of course, the more accurate, composition of HiCure, but we're focusing on the formulation of the product is focused on these key amino acids, and that's the reason behind it. But the composition is one thing, but also it's very important to understand the balance between the free amino acids and the peptides. So the form of the amino acids, it's very interesting. So you have the free amino acids, they are like little molecules, let's call it that way. And then you have short chain peptides, that is basically the same amino acids together. And then you have long chains of peptides that also they are called oligopeptides. So you have different ways how these amino acids can be applied to the plant. So in the case of HiCure, we have a balance between the smaller forms, let's call it that way, and the bigger ones. And the reason is because the plant can uptake these differently. So the smaller amino acids, the free amino acids, and the short peptide chains are like a fast release fertilizer. Let's call it that way. It's not accurate, but it's a good comparison. And the long chain peptides are kind of like a slow release chain. So with the fast ones, we are targeting an uptake by the leaf very, very fast. And then with the slow release, it will be more related as a, a residual effect in the soil as well. So this graph, what is basically showing is the composition of each amino acid. So you have free amino acids. Sorry, this is the percentage of the amino acids in the product, and then the molecular weight. So they made an analysis compared with other products in the market, and we have a certain amount of all of them, and more of the fast type of amino acids and less of the long peptide chains. So that's just to show you a comparison of the formulation. So how is HiCure uptake by the plant? As I mentioned before, the main target is foliar. The plant has an inflection point for uptake, and then it doesn't mean that more you put on, more the plant will uptake. It has a certain capability. So we will talk about that also when we go into the rates of the product. But for this particular product, because we have a good amount of short chain and small amino acids, we are targeting a foliar uptake. However, the large peptides hydrolyze and break down into monopeptides as well, and there is uptake by the roots when it goes to the soil. So in other crops, actually, they can target these type of products to the soil. Our environment is different. We are managing here turf grass that is very different from a plant in a pot, for example, where you could manage soil in different way. So as I mentioned before, HiCure, we are looking at them as building blocks of quality, because the composition of HiCure will help you with the growth, the density, and the color, and maintain this good quality that is needed through challenging conditions that basically for us in turf is almost all the time. So now I'm going to focus more into the turf under stress. So we want to understand what happens in the plant, so then we can understand how to use the products and where are the benefits. Because again, this is not like a magic product that will show you a benefit right away. We know that turf is exposed to too many stresses, I will say, at any time of the year, biotic or biotic stresses. We are going to talk about physiological stresses like heat and cold, and also some mechanical stress. We did some trials also under wear and traffic conditions. And we will look at the response of the plant when it's under a biotic stress like a disease. So how important is to have a plant that is well conditioned for this before the pests arrive or the disease. So what happens in the turf when it's under a stress condition? This is very general, but it applies to almost every stress in the plant. When the plant feels that there is a stress there, it will increase the free radicals inside of the plant, and that will reduce the photosynthesis. In the case, for example, of ice, or you have winter covers with snow and everything, it's not reduced photosynthesis, it's actually zero photosynthesis. But the turf normally, gradually, will go through all these processes, and that will also depend on how severe is the stress. It might jump to, a little bit of photosynthesis to nothing in a very short period. But in general, inside of the plant, you will have this reduced photosynthesis. You will start using all your carbohydrates, so there is a depletion there of reserves. You will have less respiration and less energy produced. That means less uptake of nutrients, less nitrogen to produce more amino acids and proteins. So all these processes slows down. And at the very end, the proteins and the amino acids that are already inside of the plant, because the plant cannot produce anymore, it starts a process of breaking down. So this is called reassimilation. And for that, the plant, when they do that, I will explain you more in detail, but when they do that, they can create a new source of nitrogen. But this is inside of the plant. It's not a nitrogen that is coming from out there. So it has a cost for the plant. So I will go now more in detail into the energy supply and conservation bit. And as I mentioned before, the proteins have different roles in the plant and different functions. They are really important, and the proteins are composed by amino acids. So again, the building blocks. So the proteins can be components of the cell membranes, can act as antioxidants and help with the free radicals. You have also PR proteins that are related with fungal defenses. They regulate the functions of membranes, the biosynthesis of the enzymes and the hormones. So proteins are really important structures in the plant. And also this makes a little bit complicated all the research that Veronica was talking about on biostimulants and these type of products, because you have so many things that depends on these, small units, that it's a whole universe, you know, of understanding turf grass physiology, to be honest with you, because proteins are the basics. So what happened, how do the plant normally produce the proteins? It's something that is dynamic. It's all the time happening. The plant will create the proteins that are needed depending on the environmental conditions and what the plant can get through, you know, the soil and the nutrients, and the plants adapt. So it's not a fixed process. Plants are normally adapting because one day is colder, next day you have sun and so on. You have the 4 seasons. So one of the ways that plants adapt is that when they need a protein and they don't have maybe the available, you know, units to create these proteins, they will resynthesize, I cannot say that in English, resynthesize the proteins that they already have. So they have one protein, they will break it down and they will create these small units of amino acids, and then they will create a new protein, and that's called protein turnover. But this process of protein turnover is a very, very energetic process, and it's very consuming. So the plant can cope until a certain point, but after that, the plant cannot do more. So what we are doing by giving the amino acids in an easy way that the plant can uptake it, we are saving the energy of the plant of breaking down more proteins to create these amino acids. So as I mentioned before, it's a very high demanding process. Normally the plant, this is a normal situation, no stress, generally speaking, will take the nitrate and the ammonium from the soil. This is another process that takes energy because you need to carry this nitrogen inside of the plant. Also some amino acids as chelators, and they help, you know, moving these things inside of the plant with less cost of energy. Once the nitrogen is inside of the plant, they start to formulate these amino acids, or they can get these amino acids from the protein breakdown. So this is just to explain you that in this whole process of protein turnover and uptaking the nutrients from the soil, we are spending energy. So if we give them the amino acids ready to go, then we're helping the plant in that scenario. And also I mentioned the osmoprotection. And the osmoprotection is related with the movement of water inside and outside of the plant and how we can conserve this water. So we mentioned before that high-curies has a lot of content of proline and glycine, and these 2 amino acids, it's well known in the literature that it strengthens the cell walls and protect them against osmotic stress. And the plant is under osmotic stress not only because of drought, but also because of heat and ice formation. So with these amino acids, if they're available for the plant again can adapt until to some extent and maintain this turgor pressure inside of the cell. So this design here is showing us a turf cell, and it's showing how it will look like if we apply, or the plant has the amino acids, the proline, for example, available. So it maintains this turgor in the cell. Now, if we don't have that situation, I don't know if you can see this little cell collapsing, it's because when you are under this stress, there are some byproducts that are produced, and the salt concentration increase inside of the cell, so the water tends to go out, so there is the hydration in the cell, and then finally the cell collapse and you can see a damage. So if you are able to apply the amino acids and help the plant to protect, to maintain this turgor, then the stress is lower. That's one of the reasons, and that's the concept behind the osmoprotection. So this is the same graph. I didn't know if the animation will work, so I back up the slide with a different one. So it's the same concept, try to maintain this turgor pressure in the plant. So I think now we are going to jump more into research and results, so more like a science-based part of the presentation. The other one was more the concept behind it, but of course we need to prove it. So in general terms, we started to do work with HiCure about 6 years ago. We did work in glass house, and then we went into the field testing. Since there was not too much information, and personally, this was a challenge for me and the team, and also for Veronica and her team in the university. We have been learning a lot through the process. We are still learning. I don't think if we will ever finish this. So we started to test different rates. Our learns from these specific products from other crops was to use lower rates, about 2.5 liters per hectare. But since turf grass is so different, you have billions of plants per unit, we thought that it would be interesting to look at higher rates. So we play between 2.5 and 100 liters. And I'm not saying that that's the rate. Don't worry. We found a rate that is absolutely more practical and affordable, hopefully. But we have information and a different range of products. Range of doses. We also tested in different turf species. So we did it at the very beginning. We focused on the main ones like agrostis, and Veronica will be presenting on that. We did test on Poa annua, Lolium, fescus, fine fescus, Kentucky bluegrass or Poa protensis, and also a lot of work on Bermuda grass. And we are right now testing it in a lot of other grasses as well, because also we have it, some customers are already starting to use it, so we will have a lot more information. Just to mention, we never had a problem with phytotoxicity or any other issue. Everything is super safe with this type of, at least this type of product. I don't think we will mention it in any other slide, so I'm just remembering that that's a key point. Never saw any problem with phyto, even at higher rates. So we had around 40 trials today, maybe even more. I tried to count, but I'm losing that counting. But we will focus today on heat stress, disease stress, and recovery. And depending on time, maybe we can look a little bit more at integrated programs, because we have been doing a lot of work with integrating this HiCure with other products like Rider, the pigment, Calibra, the wetting agent, Primo Max specifically. We did a lot of work on that, so we know it's safe and you will not jeopardize regulation. For example, that was a very good question I had at the very beginning, because you're playing with amino acids and growth of the plant. So we know it's safe to combine it. But we will try to focus today all the information just on HiCure, but I'm open to questions later for combinations with other Syngenta products. Also, we did a lot of work with fungicides as well. So I will start with heat. I will just mention one last thing before I hand over this to Veronica. And again, going back to the literature review, this is a very interesting paper from Bring-Ru Wang. He has a lot of more information out there, good quality information on biostimulants in general and physiological effects in plants. And this, in this trial, what he did was to look at the protein content in plants, in agrostis specifically, when they were under heat stress and high temperatures. So here in the graph, you can see the total amount of proteins depending on the temperatures. So when the temperatures were going up, the amount of proteins were decreasing. So that's, you know, another, it's not rocket science. We already know that the plant is under stress, so it cannot create the same proteins. But what is interesting to see as well is the amount of amino acids, the content, when you go to higher temperatures. And you can see that the content is going down, but at some point that content goes a little bit up, and that's related with this turnover that we were mentioning before, that the plant is breaking down their own proteins. So this trial was not done putting amino acids on top of it, but it shows that that's what's going on in the plant under heat stress. So knowing all that and informing ourselves and learning, we put down a lot of other trials, and Veronica will tell you more about this experience in the University of Valencia. All yours, Veronica.
Thank you. Well, this experiment consisted in 4 groups of pots where we cultivated bent grass, L93, in a sandpit soil And after 2 months growing them, we started applying HiCure at different rates, from 10 to 50 liters per hectare and a month, at a 14 or 28-day interval, in a preventative and curative strategy. Each treatment had 4 replications, and each group of each set of pods were stressed with drought, disease, heat, and herbicide. The herbicide in order to see recovery. Okay. Yeah. Oh. Me pasé. In this experiment, we obtained exceptional results on turf treated with HiCure at 25 liters per hectare, applied in a 14-day interval and in a preventative strategy. We applied HiCure 2 months previous to inducing stress, and here you can see in the picture the turf status after 4 weeks. I don't know what happened. Guilty. Yeah. This picture shows the turf status 4 weeks, 4 weeks under heat stress. Heat 27 Celsius degrees. After 4 months, this is the 4 weeks. Sorry, this is the situation. In this case, we prepare. This is the herbicide. Yes. In this case, we prepare the turf applying HiCure during 2 months for a herbicide application. This is not a typical stress, but we would like to know how HiCure behaves. So we apply bispiribac sodium. Bispiribac sodium is a herbicide which inhibits the synthesis of amino acids. So we thought, well, HiCure could help the plant providing the amino acids that the plant could not synthesize. We saw again, as you can see in the picture, that took 2 weeks after the herbicide application. Turf treated with HiCure at 20 liters per hectare in a 28-day interval, compared to an untreated and stressed turf, HiCure kept good turf color values, as you can see also in the graph. This is an untreated and stressed turf, and here 20 and 50 liters per hectare, for example. The picture corresponds to the same experiment with the herbicide, but here 4 weeks after the stress application, after the herbicide. Turf still kept a good turf color compared to an untreated and stressed turf, as you can see. Well, and now let's move into disease tolerance. Well, we really like this picture as it shows how HiCure prepared turf for a disease attack. For this experiment, we applied HiCure in a preventative way at different rates as in the other experiments. And after 2 months applying HiCure, we inoculated dollar spot, which is a very aggressive disease cited in Spain on creeping bentgrass, as well as in Norway and Sweden. For that reason, we are showing these results. Disease was inoculated by spreading a known amount, of dollar spot inoculated wheat grains over the pot surfaces, as you can see here. These here are the wheat grains. The picture shows that the mycelium in the turf that received 50 liters per hectare of HiCure applied every 28 days didn't develop mycelium as in the untreated and stressed pots. The pots treated with hybridion didn't allow disease to develop, but the turf treated, as in the turf treated with HiCure, yes, there was infection, but slowly compared to the untreated turf and stressed. So HiCure, we could say that HiCure prepared turf for that stress. 3 weeks, 3 weeks after the inoculation, this was the situation. The fungicide received the best values, the best quality values, sorry. But the turf treated with HiCure at 25 liters per hectare or 50 liters per hectare showed great turf quality compared to an untreated and stressed turf, as you can see here. This graphs belongs to the same experiment, but here you can see the disease development. Here we, at this point, we inoculated the disease, the tolar spot disease, and you can see that the different management, the response of the turf under different management, the fungicide. Sorry, this is the untreated and stressed turf, which has the greatest, the highest percentage of disease, and here the hybridion treated pots. In the middle, HiCure at 50 or 25 liters per hectare. Here the picture, 8 weeks. Sorry, at the end here, untreated and HiCure at 50 liters per hectare. Thanks to this pot experiment, we were able to move the experiments to field conditions. Yeah. We conducted 2 experiments at the Manises Royal Golf Course in Valencia, here in Valencia. In this picture, you can see how we work in field. 11 treatments, 4 replications. We always use a plastic mold that fits perfectly with the plot size, sorry. And that the use of that mold prevents wine drift to the other plots. And 6 weeks after disease appearance, the same experiment. 6 weeks after disease appearance, the turf treated with HiCure in a 14-day interval was prepared to tolerate an attack of tolar spot. At this point, the pictures, HiCure was applied 10 times. We applied HiCure in a preventative way, then disease appeared. And we still applying HiCure after the disease appearance in a curative strategy. And this is the result, very positive. And this is yours, Marcela.
I think I'm gonna do this one. I'm just looking at the time and we are getting close to the time, so I will move a little bit faster. Veronica was showing, you know, she was the one taking the measurements, doing the assessments for all the work in Spain that we continue over the years. And I can tell you that the greenkeeper for that golf course was not very happy at the very end, because I mean, all the treatments work well with the fungicides and HiCure, but the untreated was not looking good. I don't know if you have the same kind of level of tolar spot down there, but since it's described now and you are starting to see it more and more often. But we did a lot of work with other diseases as well, and the trend was the same. I'm going to show you very quickly a trial that we did here in the UK with microdocument patch. So this was in the fall. This is more relevant for you guys probably because of time of the year as well. And we did it with lower rates of HiCure. So here we were looking at 5 liters every 14 days. This is one of the best results, I will say, because it's very similar to a fungicide treatment. We did 2 preventative applications. That's very important. All the results that we have seen so far, the going preventative is the key thing, I will say, because we did it curative as well, and then the results are not the same. So you might get good results, but it's not so reliable. So with the amino acids, absolutely go before the stress and continue in the program. But I will say that this graph shows something that is more accurate to reality. We are not expecting that this type of products will be like a fungicide or like a normal chemistry type of products. It's not the intention by any means. But you can see that the yellow line is how HiCure was doing at 5 liters per hectare, and it's in between the control and a fungicide standard program. So it's doing something, I will say, maybe 30 to 40% decrease or better tolerance to a disease. And we saw the same with other diseases as well. So this is a picture of the microdocking patch at STRI. So the level of disease was not so high, but still HiCure was looking better turf quality. We had the same with anthracnose as well, and same trend. Now, if I look at the programs, I don't have too much time to show you programs in combinations with other products, but if you want to use HiCure, we are looking at applications to make the plant more resilient, so meaning surviving, for example, over winter. So applications in your countries could stand as soon as the end of the summer, beginning of the spring. So you condition the plant to have a better spring growth and recovery in the next season, in the spring. We did a very interesting trial with Veronica as well in Spain on Bermuda grass, that we saw a green up of the Bermuda grass, absolutely amazing this year. Maybe for a next webinar, we can show it to you. It's in Bermuda. I know that you are not in Bermuda, but the concept is, it's very similar. Plant go dormant. Some of the Bermuda, well, this year is not even showing that dormancy, didn't show that dormancy at the beginning of the year. Programs for winter quality and spring recovery, as I said, rate is kind of flexible. We are looking at 10 liters every 2 weeks because you are under a lot of pressure right now. And then during the winter, if you have a snow cover, then of course you stop it, but you can resume it and start again during March, April period when the snow cover is out. You can tank mix it safely with Primomax. As I mentioned before, I did all the studies to see if the regulation was jeopardized by putting amino acids, and it was completely safe. You don't lose the regulation. It works perfectly well. And also it combines well in the tank. So you can do it together. We are looking at 5 to 10 liters every 2 weeks. You can continue the applications during the spring, summer, and early fall with no problems. Again, it will depend what stress you are trying to target, but it combines very well for summer stress, meaning heat and drought together. Actually, the best results is when you combine Primo, HiCure, Rider, and Calibra. Then you're targeting different modes of action, even if they're not fungicides. I will use the same word because they're all act the same. So best use guidelines, start the HiCure before the stress begins, use it in a program every 2 weeks or every 4 weeks, depending on the rate that you are going for, 5 liters, 10 liters, 20 liters. Integrated with Primomax in the spring and summer, works very well, can be tank mixed with fungicides if you require it. We did that work as well. Use higher rates for the months that you have more challenging conditions. Maintain, of course, the good ITM practices and aeration in your greens. 200 to 400 liters of water per hectare is the recommended water volume for tank. As I mentioned before, cold, heat, drought, disease, and recovery. We didn't touch base too much on seedling and also establishment, that we have seen good results with it. In germination as well. And I will say that that's most of it. Just to finish, compatibilities with some of the products, we of course need to update this for each of your countries. We have the information, we have run the compatibility test with most of the products from our distributors in each country. I apologize if I don't have everything from other distributors here, but we are building this list and you should be able to get the information with no problem. So I think that's us. I appreciate Veronica's help as always. Many thanks working with you guys. It's been really amazing. I'm learning so much, and the fact that we can do the presentation together and show our own result is always very positive. So thank you, Veronica, and thank you, Lars, for organizing. And I'm happy to take any questions or Veronica. So.
Thank you very much, Marcela and Veronica. Thank you for a very good session. We have some minutes left for the Q&As. We have one question coming in from Agnar and Marcela and Veronica. The question is, what was the control that you compared HiCure to? Nothing applied or similar rates of nitrogen?
No, nothing applied.
It depends on the trial.
Yes.
Because Veronica is speaking about some of her trials. But in most of the cases, I will say 80% of the cases of trial work that we have done, we have compensated the nitrogen. So that means that the untreated receive the same amount of inorganic nitrogen as the other plots. So Veronica can help me with the calculations because we did it together at some point. But for example, the golf course, the drought one that we did this year, we calculated that if we put 20 liters of, I don't know, HiCure, then we need to put, I don't remember, like 1 kilogram of nitrogen maybe to the other plots. But
we compare a higher rate of HiCure with a normal nitrogen fertilization. In that case, we applied 60 kilograms of nitrogen.
Oh, that's another treatment. You're right.
Yes, and that was the highest HiCure rate. Yeah, 100.
So Veronica is right, because we have been doing. Sorry, I have like 40 trials in my head to answer that question. So normally we compare it with the untreated that receive nothing but the nitrogen amount that HiCure is giving. In other trials, we actually compare it to a nitrogen, like a high fertility treatment. So we put, I don't know, the highest amount of nitrogen possible. So we have those comparisons as well. But what we are presenting to you now, that was the comparison.
Okay, thanks, Marcela. Thanks, Veronica. Agnar, was that answer to your question?
Yes, it was. Thank you very much.
Okay, thanks, Agnar. Okay, we have another question from Hans. So what about effect against anthracnose?
I'm prepared for that question.
Yeah.
Yeah, I kind of missed the answer there. Was it the same as some other disease?
I have this one in anthracnose,
yeah.
So I think this is a good example. Let me see if I can show it to you. So I went a little bit fast with some of the slides. So this was in Bingley in the UK, 2017. We ran different trials with anthracnose. So here you can see the turf quality and the dates, and you have the green line. It's a new fungicide from Syngenta. Then the gray line, it's HiCure at 10 liters every 28 days, and then you have the untreated, that is the lowest line. And then the blue, that is HiCure at 25 liters. So basically 2 rates of HiCure in a different type of interval. And the stars are showing you the significant differences. So if you look at the fungicide and anthracnose, obviously there is a big difference. But HiCure again has the same trend to be kind of in the middle. So giving you that 30 to, I would say between 20 and 40% better performance under anthracnose. So this is one example of the trials. We have a couple of more, but I think this tells the story better because it's very similar to what we saw with microdocium. With dollar spot, it was even better, but again, I don't want to overpromise things with diseases because it will depend on the pressure that we have. But this is the tendency that we have seen, at least in, I don't know, maybe 20, 30 trials that we have been doing the last 5 years. So it definitely shows that the plant is better prepared.
Okay, thank you. for your answer.
Thanks, Marcella, again. Thank you for the questions. Any more questions coming up, please? If you have any, just go ahead.
It was so clear, the presentation. Yeah, well, if you have any other questions later, just email Lars. That's not a problem.
Yeah, thanks. I think Magnus, you just raised your hand. You have a question? Magnus, are you there?
Maybe he was saying goodbye, Lars.
Maybe he's saying goodbye. It might be. I don't know. It could be. I don't know. I just saw he raised his hand. So if he wanted to ask a question, he could go ahead. But yeah, no.
Yeah,
sure.
Yeah. No, go ahead. I think I might have a question.
Oh.
Maybe for you, Lars.
Uh-oh.
Uh-oh. Trouble. Now, how severe was the drought this year down there? Because here in England, we have some weeks of very, very strong droughts, but then it was leveling up with the rains. Spain is always drought, but I'm not aware how bad it was for you this year down there.
Firstly, we've been like we have the COVID situation, so I have not been able to travel. And honestly, first of all, I have been. I'm living in the west coast of Norway, so we really don't have a problem with the drought. It's raining more or less every day, so no drought here. But I think we did have some weeks of dry weather in Stockholm area as well, and I think in Sweden, south of Sweden. But it wasn't a severe long drought as we had 2 or 3 years ago. Was it? We had really long drought, which was really a problem. But,
I'm asking that question because now also we are finishing another trial at STRI that is called. Well, we did the lockdown trial where we did primo applications in a lockdown situation, but then we did another trial called the Unlock and Play trial that is finishing now, and we included also HiCure in that program, and we are getting some interesting results in terms of the management when you don't know how the year is going to be, and what about putting this extra support to the plant under conditions of high play, and also with weeks that are drought and dry and wet as well. So we are going to be sharing that. We are sharing that online, but then we will probably have a summary of all that data very soon. So it might be interesting maybe for your countries as well.
Yeah, perfect. Thanks, Marcella. Actually, Hans, again, he commented, he says it was tough in the southeast of Sweden and the third year in a row. So it was quite tough this year as well, I understand.
Yeah, because I will say that HiCure, we have done a lot of work with Veronica as well, because they have the drought and also they have the dollar spot, and they have a heat. Heat is very similar in terms of physiology responses for the plant as cold tolerance. We're also now placing a new trial. To be honest with you, I was hoping to have trials with cold chambers today, but because of coronavirus, the work got delayed. So that's something that we are hoping to have by next year. So we're testing HiCure in growing chambers under cold conditions too. So yeah, hopefully by next year you can have more on that. But yeah, I was curious about the drought one.
Perfect. Thanks, Marcella. Okay, any more questions? We still actually we are now spot on time, so I don't know if you have any more questions. I guess we can still do 1 or 2 more. So I can't see any more questions coming in on the chat, so unless I don't know if Magnus has taken his hand down again, but it might be. Okay. First of all, thank you again for your presentations today from Marcella and Veronica. Thank you very much. And then I want to remind you all on our next webinar, which will be in 2 weeks exactly, at the same time. and the same channel. And that will be then Rod Burke will talk about use of rider turf pigment in autumn programs. So that's going to be another interesting and learning full webinar. So hope you will join us then, and please share this message to all of your friends and colleagues to join. That'd be great, because we hope to see you all here in 2 weeks. All right. Thanks to all of you. All the best.
Thank you.
Cheers.
Have
Thank
a
you.
great week. Bye bye.
See you. Bye bye. Bye.